Okay, in this video we're going to talk about preparation of alcohols by substitution and addition. And this is really a review of reactions that we learned last semester. Okay, so last semester we learned some reactions where we could make alcohols from alkyl halides via substitution reactions. And then depending on the nature of the substrate, this is either going to occur through an SN1 or an SN2 mechanism. So the two reagents that we would use to convert an alkyl halide to an alcohol would be hydroxide ions or water. Now, hydroxide ions are a strong base and a strong nucleophile, so hydroxide, something like NaOH or KOH, would be effective if I have a primary alkyl halide that would proceed primarily by an SN2 reaction. Now, water is a weak base and a weak nucleophile, so it won't react with primary or secondary substrates, but if I have a tertiary substrate, I can use water to get an SN1 reaction. Now, unfortunately, if I have a secondary substrate, substitution is not particularly effective because in the case of hydroxide, that's going to prefer elimination, and in the case of water, it's going to be too slow to be effective. An effective synthetic pathway. All right, so just two examples from things we talked about on the last slide. If I have a primary substrate, I can react that with hydroxide. That will proceed by an SN2 reaction to give me a primary alcohol. If I have a tertiary substrate, I can react that with water. It'll proceed by an SN1 mechanism to give me a tertiary alcohol. If I have a secondary alkyl halide, as we talked about on the last slide, substitution is not going to be an effective way to convert that into an alcohol. All right, we also learned some addition reactions last semester that can be used to synthesize alcohols from alkenes. And I have the three examples. So we have, in this case, we're going to get acid catalyzed hydration. This is oxymercuration, demercuration, and then we have hydroboration, oxidation. I'm actually going to do them a little bit out of order. I'm going to do oxymercuration, demercuration first. In this case, we're going to get Markovnikov addition of the OH. So the OH is going to end up on the more substituted carbon. So my product in that case, now when I add the OH here, I'm going to be creating a new chiral center. And so this reaction is not stereospecific. So I'll get that compound, and it's an enantiomer. Now, the reason I did them out of order is because acid catalyzed hydration is also going to give me Markovnikov addition of the OH, but carbocation rearrangement is possible. And so in the mechanism for acid catalyzed hydration, I'm going to get a carbocation on the more substituted carbon. Then I can get a hydride shift. So one of the hydrogens here will move over. That'll put the carbocation. It'll give me the more stable tertiary carbocation. And so the OH is actually going to add here in this case. Now, this carbon does not end up being chiral, so I don't have to worry about showing any stereochemistry. But so the important thing to remember, if I want to avoid carbocation rearrangement, I need to use oxymercuration, demercuration if I want Markovnikov addition of OH. And then finally, the hydroboration oxidation will give me anti-Markovnikov addition, so the OH is going to go on the less substituted carbon. And so our product in that case will be that. And again, no new chiral centers were formed, so I don't have to worry about any stereochemistry there. All right, so just two quick examples. What reagents would I use to accomplish the following transformation? So I'm starting with an alkyl halide. I'm going to an alcohol. I have a primary alkyl halide, so I can achieve this through a substitution reaction. And I'm going to go for SN2 because it's a primary substrate, so I'm going to use NaOH in that case. Okay, one more example. In this case, I'm starting with an alkene going to an alcohol. So this is going to be an addition reaction. And I can see that I've got an anti-Markovnikov addition. The OH went on the less substituted carbon. So for that, I want to use hydroboration oxidation. All right, so there's several more examples of these types of problems in the textbook, so I encourage you to give those a try to refresh yourself on some of the reactions that we learned last semester.